Assalamualaikum and hello. So I'm going to continue our next video, which is about our second part for the second subtopic, empirical and molecular formula. And in this video, we are going to focus the method, which is the third method to determine the empirical formula specifically from combustion data. So, I have one example 7, where I got a sample of compound with 1.00 gram was burned in excess oxygen to produce 2.52 gram of carbon dioxide and also 0.443 gram of water. And in this case, I want to determine the empirical formula for this compound A. So what I'm going to do, I'm going to use the solution by using mole concept. So in theory, in 1 mole of carbon dioxide, there is 1 mole of carbon. And then in 1 mole of H2O, we have 2 moles of hydrogen atoms. So elemen yang kita fokus di bahagian ini adalah elemen carbon and also elemen hydrogen. How about elemen oxygen? So elemen oxygen ada dekat dalam CO2 dan juga H2O. So what we're gonna do, kita akan tolak dengan total mass at the end of our working solution. So kita fokus dahulu untuk how to find out the mass for carbon and the mass for hydrogen. Kita tak boleh guna the mass of carbon is 2.52 gram sebab this mass is for carbon dioxide. So we have to find out based on mole concept. So let's continue with solution part 1. I use this statement that I mentioned before. In 1 mole of carbon dioxide, there is 1 mole of carbon atom. So kita compare dengan mass untuk carbon dioxide. In general, bila awak tambah total mass of carbon dan juga 2 oksigen, awak akan dapat 44.0 gram of carbon dioxide. It means that you have 12 gram of carbon atom. So, what you gonna do, ini adalah secara teori. And what you have from the question is 2.52 gram of carbon dioxide. So, it means this is the mass that you want to find out. So, this is from question. So, secara teorinya, what you gonna do, di mana awak akan buat comparison between carbon dioxide dan juga carbon atom. So, this is what you will have. Sebenarnya, ia sama macam konsep awak buat darab silang, di mana I have over 44.0 equals to X over 12.0. So, bila awak darab silang, awak akan darab like that. And what you will have, mass of C atom, dalam case ini adalah X, is equal to 12 over 44 times 2.52. So, awak akan dapat mass of C atom adalah 0.6873 gram. So, please be careful. Okay, next one. What we're gonna do for solution part 2, di mana kita nak fokus tentang mass of hydrogen. So, 1 mole of H2O, kita ada 2 mole of H atom. Di mana kita dapat 2 mole, kita ada formula H2 dekat sini. So, itu maksudnya 2 mole of hydrogen atom. And then, what's next? This is from the statement. In theory, based on the mass, saya ada 18.0 gram for H2O mass. And, of course, I will have 2.0 gram of H atom. Sebab kalau untuk satu sahaja H atom, kita ada 1.0 gram. Tapi sekarang kita ada 2 mole of H atom, so it means 2.0 gram. So what we will have, kita akan continue di mana ini adalah berdasarkan soalan. I got 0.443 gram of carbon dioxide, which has X gram of H atom. This is what I'm going to find out. So, do the comparison. You will have between H2O and H atom. So, darab silang macam biasa. So, therefore, you will get mass of H dalam kes ini adalah X awak, iaitu 0.0492 gram. So, this is the solution for carbon and hydrogen. Next one, solution part 3. This is the last working solution that you have to show, where you want to calculate mass of oxygen. So, mass of oxygen, di mana kita akan teruskan daripada total mass yang kita ada, iaitu 1.0 gram. So, this is the mass of sample, in this case is compound A, minus with the mass of carbon plus mass of hydrogen that you got from solution part 1 and part 2 respectively. So, the value for mass of oxygen is 0.2635 gram. So, this is how you calculate when you got the question based on combustion data. But you have to put in Marmora table based on element. Sebab tu kita gunakan 3 parts of solution in this case to calculate each of the mass for each elements yang kita ada, iaitu CHO. So, let's continue with our Marmora table. So, this is part 4, where Marmora table as usual we have mass in gram based on elemen yang kita ada. So, biasanya combustion data elemen yang terlibat selalunya carbon, hydrogen dan oxygen, sebab kita buat combustion with oxygen. So, next one kita ada mole. So, my unit is mole, jangan lupa. And then I have simplest ratio. So, what I'm going to do now, I'm going to put the value that I got. So, I got 0.688 gram for carbon, 0.0492 gram for hydrogen, and 0.2630 gram for oxygen. Jangan bunda, use the value as it is, especially kalau value tu 4 decimal places, it is more favorable to use that in your working calculations. So, next one, I want to calculate the number of moles. So, I will have number of mole for carbon is 0.0573, and I will have number of mole for hydrogen is 0.0492 over 1. So, this is the same value for my number of moles for hydrogen. And then, I got the number of mole for oxygen, which is 0.0164. Okay, dalam kes ini, kita akan bahagikan berdasarkan elemen yang ada. So, elemen kita hanya satu sahaja mole dia. So, sebab tu kita bahagi 12, 1 dan 16. Sorry, bukan number of mole, ia adalah bilangan. So, hanya ada satu sahaja. So, next one kita akan continue dengan simplest ratio. So, my simplest ratio right now is based on the smallest number of mole that I have for each element. So, daripada 0.0573, 0.0492 and 0.0164, the lowest or the smallest number of mole is oxygen. So, 0.0164 will be our pembahagi. So, saya akan letakkan dalam saya punya calculation of simplest ratio, where I have 3.49 as my simplest ratio for carbon, and I have 3.00 simplest ratio for hydrogen, and I have 1.00 simplest ratio for oxygen. So, in this case, saya tak boleh bundakan di mana untuk whole number for this carbon kepada 4. sebab dia sangat jauh. So that's why value dia agak jauh. Kita tak boleh round off straight away. So what we're gonna do, kita akan times with factor number. So bila kita times with factor number, awak akan times with 2. Kita do it one by one. Jangan terus time by 3. Terus time by 2 dulu. Barulah awak akan dapat nilai factor tu sama ada boleh bunda ataupun tidak. So dalam kes ini, saya memang akan dapatkan hydrogen saya 3 and 1 as my value. But bila kita times carbon sahaja, semua perlu times with factor number. So for carbon, I times with 2. Hydrogen, I times with 2. And oxygen times 2. So what we'll do now, saya akan dapat 7 untuk carbon, which is this case sebenarnya nilai dia adalah 6.98, approximately 7. And then untuk hydrogen I will have 6 and oxygen I will have 2. So boleh tak saya tentukan empirical formula sekarang? Yes. So do your conclusion, which is empirical formula is C7H6O2. So di sini pentingnya bila awak punya calculation awak tak bunda daripada awal, awak gunakan 4 decimal places as it is dan awak akan dapatkan range value yang betul. So that's it for this video. I leave it to you. Try this 3.0 to enhance your understanding. And try to do that. I put the final answer here for this question. So hopefully you can try to do it. So that's all for this video. The next video we are going to continue with the third subtopic. Thanks for watching. Bye.